This is my Lab 6 demonstration. This is the code. I have it Lab 6_1 because this is the second part. This is GPIO connected, and yeah, this is where we actually implement tasks and change the code. So you can see I have the includes and the defines and the XGPIO and the status / initialization for the GPIOs, and everything else is pretty much the same for the base code given in the manual. I did commented out the sleep and the print because we need a higher sampling rate to actually do these tasks better, and the print just gets sloppy on the terminal. I'm actually going to go ahead and clear the terminal right now, and yep, and I'm going to have it set to 0, or the switch input to 0, and you're going to see EC 3622 Lab 6 print out about every 5 seconds, which would be for A. So right now I have the switches all low, and that is printing out, so that would be this piece of code right here. I just did a basic for loop just because that was pretty easy, and I got it to work, and I knew it was about this value for 5 seconds, so that's printing out down here. This is task 4B, which does the bar graph. So in the waveforms, I have, I'm gonna make this full screen. Maybe not full screen, that's a little too big. Just a little bit bigger for that. Okay, so I have 100 millisecond or 100 millihertz, amplitude of 1. The output should be 0. It does this. It starts at -1. I have not figured out how to get it to start at 0, so that is what it is. It doesn't really change what's happening too much. It does affect what the output is, but it still works fine. So I have this running. Currently have it about, it's 76.6% symmetry. So I'm going to flip switch 1 on, and we're going to see the LEDs light up soon once it gets out of that for loop for task 4A. So it started about halfway through that, or more than that since the 3 were on, and it's going to light up relatively slowly, and each LED is a threshold for the input voltage. It's 0.2, 0.4, 0.6, 0.8 volts, and as long as it's above that threshold, the LED will be on. That's why they go on in order and stay on once they're on, and then they go off once this ramp resets here. So it comes, and about here the first one goes on, and then about here the second one and the first one go on, and then so on and so forth. If I decrease the symmetry rapidly or significantly, you're going to see how much faster the lights go on once it turns off and the pulse is done. And all 4 are on during the pulse. Yep, that was very quick. And the pulse is just this part of the flat. So do that again just in case it did not seen. This is a symmetry of 10%, and it goes very rapidly. Now the pulse stays on for a while, especially on those. Well, I just changed the input, so it's going to be very slow because now the symmetry is 93%. And the symmetry, the higher the symmetry, the longer the ramp, and the lower the slope of the ramp, and the shorter the pulse. And the pulse is when it reaches that maximum, and it stays at the pulse for the whatever 100% minus the symmetry. So the symmetry is just the amount of time it's in the ramp. So it's the higher the symmetry, the lower or the slower these lights are going to go on, and the lower the symmetry, the faster they're going to go on. I think that was a little just lag error. And I'm going to show this last task, which would be task 4C, which is the switch 2 on. And then I did it where if both switch 1 and switch 2 are on, just nothing happens because there's nothing specified, so it's just running and nothing outputs, nothing happens. So as you can see here, the symmetry is 93.3 still, and what prints out is this line. It is 3 nths, and it is the ramp. It is samples of ramp, samples of pulse, and then the calculated symmetry. I had problems with getting it to run where it actually gave me any decimal values, so I just calculated to the nearest, or not even to the nearest. I just rounded down, so I just cut off any value that would be after. And I mean, for 93% symmetry, calculation 91 is pretty dang close. I'm going to move it down to, yeah, that's fine, 27.9, so about 28. This first calculation will probably be wrong just because it changed halfway through and it might get some weird, no, it's okay, 27, yeah, 27 symmetry for 27.9 input symmetry, so that's spot on actually, considering it's still, we're just outputting an integer. That's actually perfect. Yeah, so I think that's 4A, 4B, and 4C. Again, that's just switch 2 on. These do nothing. I hit the other buttons on that. That's why things are weird. Yeah, those buttons do nothing. I also have some issues with the connection, so I was moving the board a bit. That's what I was getting the wacky symmetry. That's why I have all this tape, and I've definitely had some connection problems, and I'll show you that during the slave select portion of this demonstration, which I will just add on to this afterwards, but I will get it all set up and not waste your time for that. So that's it for the second part of this lab. Thank you.